Hello, my name is Professor Adrivan, and in this standalone video, we're going to look at how to multiply and divide rational expressions. We're going to follow the normal format where we look at three examples. The three examples that we're going to be doing are on your screen now. So if whatever you're working on, homework or otherwise, look like these problems, then this is the correct video for you. Let's go ahead and jump into it. So with our first example, we're taking two rational expressions, 3x over x plus 1, and x squared plus x over 3x minus 6, and we're trying to multiply them. Alright, so recall how to multiply fractions. Right, multiplying fractions is the most convenient because we get to multiply straight across the top and straight across the bottom. Okay, so we can say that this is equal to 3x times, right, the numerator of the first, times the numerator of the second, x squared plus x. We're going to do the same thing with the denominator. We have x plus 1, the denominator from the first term, or the first expression, times the denominator from the second expression, 3x minus 6. Now, I highly recommend that you do not distribute and FOIL these out right now, because you won't see if things are going to cancel. So instead, what we want to do is factor any of these terms that we can possibly factor to see if something's going to cancel. Looking at the numerator, 3x, we can't really do anything to that, but x squared plus x, we can factor out an x, leaving us with x plus 1. And in the denominator, x plus 1 we can't do anything with, so it's going to stay the same. But the 3x minus 6 term, we can factor out a 3, leaving us with x minus 2. Alright, so the purpose of doing this is so that we have a number of terms that are all being multiplied in both the numerator and the denominator. And when they're all being multiplied, we can take advantage of the idea that if something's being multiplied in the top and in the bottom, we can cancel it out. Right, so there is an x plus 1 on the top and on the bottom. We can cancel that out because what's the point in multiplying the numerator and the denominator by the same thing, right? It's going to affect it the same way. That's just extra work. We can just get rid of that term. We also have this 3, right? This 3 in the denominator, and there is a 3 being multiplied by this x in the numerator. Right? That 3, that constant, can also cancel out. Again, for the same reason. What's the point in multiplying all the terms in the numerator by 3 if we're also going to multiply them all in the denominator by 3? Okay, so what are we left with? Well, in the numerator, we have an x times an x, or x squared. And in the denominator, the only term left is x minus 2. So this would be our final answer. Okay, so to recap, we multiply the numerator straight across, and we multiply the denominator straight across, but we don't want to actually multiply them. We just want to write those terms together as if they're being multiplied, like we did in this first step in red. Then we analyze both the numerator and the denominator to identify anything that can factor. And once we have things factored, we look for similar terms in both the numerator and the denominator, cancel those similar terms out, and whatever we're left with is our simplified expression. Let's look at another example. In this case, we have a rational expression, x plus 2 divided by x squared minus 4, and we're multiplying by a binomial, x squared minus 2x. Alright, we know how to multiply fractions, but this second piece is a binomial. It's not a rational expression. But we can easily turn this into a rational expression simply by putting it over 1. Okay, so we can take any polynomial that is currently not a rational expression and put it over 1 to make it a rational expression. And then we can continue just like we did in the previous problem where we multiply the numerator. And by multiply, I mean just write the terms next to each other. So x plus 2 times x squared minus 2x. And do the same thing with the terms in the denominator. x squared minus 4, and we'll put the 1 here just to be complete, but it's not needed. And then I want to factor anything that I can factor. So in the numerator, I have x plus 2. We can factor an x out of the x squared minus 2x. And if we factor out an x, we're left with x minus 2. And in the denominator, we have this difference of two squares. So recall that a squared minus b squared is equal to a plus b times a minus b. All right, so we're going to use this to factor the x squared minus 4, and it'll factor into x plus 2 and x minus 2. So now I want to analyze the numerator and denominator for any similar terms and cancel them out. And we can cancel them out because everything is being multiplied. So there is an x plus 2 in the numerator and denominator that will cancel, and an x minus 2 in the numerator and denominator that will cancel. So this leaves us with just an x. All right, so multiplying this all together, when we simplify, we get just an x. Convenient. Okay, we have one more example to do. And in this case, we're taking two rational expressions and we are dividing them. All right, so division is a little bit different. It just adds one step in the very beginning. So we're going to take the first piece, this 1 minus x squared, divided by x squared plus 3x minus 4, and we're going to keep it. We're going to change the division to multiplication, and then we're going to flip the second rational expression. So I'm going to flip it to x plus 4 over x plus 1, right? KCF. Keep, change, flip. That's how we want to think about dividing rational expressions. Okay, because dividing fractions, right, dividing by this x plus 1 divided by x plus 4 is the same thing as multiplying by the reciprocal. That's why we change the division to multiplication and why we flip the fraction, because it's the reciprocal. All right, so now that we have it as multiplication, we can approach it just like we did in the last two examples. We can take our numerators, 1 minus x squared and x plus 4, and write them as two terms being multiplied. And we can do the same thing with our denominator, x squared plus 3x minus 4 and x plus 1. So from here, we want to factor anything that we can factor in both the numerator and the denominator. And again, I see this 1 minus x squared, that's in that a squared minus b squared equals a plus b times a minus b. It's in this form again. So because it's in that form again, we can factor it. We can factor the difference of these two squares into 1 minus x and 1 plus x. The x plus 4 we can't do anything with, so we'll just keep that the same. And in the denominator, this x squared plus 3x minus 4, this quadratic, we can factor it, and it factors pretty straightforward, into x plus 4 times x minus 1. And then we also have this x plus 1 that we can't do anything with, so we'll leave that there. All right, so notice a couple things. X plus 4 and x plus 4 is in the top and the bottom, so we can cancel that out. 1 plus x is the same thing because it's addition, the order doesn't matter, as x plus 1. There's an x plus 1 in the bottom, so we can cross that out. So even though they don't look exactly the same, because I can rewrite 1 plus x as x plus 1, we can cancel them out. That is not true for this piece. It is not true for the 1 minus x. We cannot rewrite this as x minus 1 and cancel it out with this term in the denominator. Okay, that will not work. Okay, so we would say that this is equal to 1 minus x over x minus 1. Now think about this numerator for a second. is there a way that I can turn this numerator into x minus 1? We just said that we can't flip the order of them, right? But we could make it the same, we can make it very similar by factoring something out of the numerator. If we factor a negative 1 out, that will change the sign of the positive 1 to a negative 1, and it'll change the sign of the negative x to a positive x. So now, this is an addition between these two terms, the negative 1 and the x. So now we can rewrite it just like we did with this 1 plus x as x plus negative 1, right, which is the same thing as x minus 1. So now we have an x minus 1 in the numerator and denominator. We can cancel them out, and we're left with this very lonely negative 1. But that is our final answer. It is the simplified form of these two rational expressions after they've been divided. Well, that's all of the content for this video. So if you found this video helpful, consider giving it a like and consider subscribing to the channel. Thanks for watching, good luck, and we'll see you in the next one.